So more vocab words. Toxicology is basically the study of harmful effects on humans and the environment. The response is basically the effect. Whatever the effect is in you, that would be your response to that chemical or whatever. And then the threshold level is basically the level at which no ill effects are occurred, and when no one's killed. So the LD50 that you guys are doing in your lab is basically, it's the point at which 50% of the organisms are killed, or the lethal dose to 50, that's what that means, LD50. Or you could also do it if you're a glass half full kind of person, the point at which half of the people live, or half of the organisms exposed live. So then the product life cycle, a lot of these chemicals, we have to now track them. They call it from cradle to grave. So from where they're manufactured until where they're disposed of. Okay. So they have to track them all the way. So this is just an example of like looking at a product where you're mining it and then you're refining it and it's transported, and then you buy it somehow and then it pollutes somehow, and then it gets if it's not released into the air, if it's like a liquid chemical, usually you have to dispose of it in a specific way, and then they now make you write these things down. So basically, now that's what this toxic release inventory is talking about. Okay, so here's our LD50. I know I just mentioned it again. There it is again. It's basically which 50% of the population is killed, or 50% survives. And then a poison is something that is any substance that has an LD50 of less than 50 milligrams per kilogram. So you can see here, I have this list, and things that are essentially non-toxic, like sugar, right? You have to have over 15,000 milligrams per kilogram in order for sugar to make you sick. Slightly toxic is 5,000 to 15,000 milligrams per kilogram. So that's like ethyl alcohol, for example. And then toxic is aspirin. That's why they suggest you don't take a bunch of aspirin, all at once, or take a lot of aspirin over a long period of time. And then caffeine, right? That's like coffee and stuff. And then codeine is very toxic. Cyanide is extremely toxic, and super toxic is stuff like nerve gas. Less than 1 drop, you'll have some sort of effect. Okay, so it's very. These are just some official designations. And then with these, we can create what they call a dose response curve. And this gives us just like a visual for how organisms react to doses of a chemical. And so these doses tend to have a very typical shape. And in here, you can see the threshold dose and the LD50. So let's see. Let me point out these. So your threshold dose is going to be right here at the bottom when you start actually having some sort of effect, right? You're going to have a threshold dose. And then your LD50 is when basically your response, your death is 50%. We'll call that the LD50. So this dose is 20 milligrams per kilogram, and that is the lethal dose for these, whatever this chemical is in this picture. Here's a couple definitions. So pollution is basically anything in the environment that, for whatever reason, prevents the functioning of natural processes and is has undesirable effects. And that's actually the definition from the EPA. In this picture, you can see a few examples of pollution, air pollution or water and land pollution, some places where they come from. So you can see, so we've got like CFCs here. These are the guys that are responsible for depleting the ozone layer. Got acid forming compounds that'll do like acid rain. Particulates, that could be like if you've ever been in an area where it's real smoky and you get that that smoke dust almost, the ash falling it all down. That's like a particulate. We can have nutrients oversupply. That's going to come from usually runoff. Solid waste, any sort of solid waste getting into the water of the land, toxic chemicals, and then pesticides or herbicides, which we just, again, a lot of that is runoff or percolation into the soil. So those are some of the ones that we've talked about so far. So this unit also talks a little bit about human health. And so basically, every primary and secondary pollutant is a threat to human health. And while we're talking about primary and secondary pollutants, there's not always a lot of time, so I'm going to tell you you need to memorize something. The concepts, that kind of stuff is more important usually, but I would know the primary and secondary pollutants, air pollutants. Those are important, and they'll ask you about them. As you can see, I think the FRQ for the air pollution unit, they'll actually ask you what's a primary pollutant. I think it's that FRQ. It might be this unit. But anyway, one of the FRQs says what is a primary or secondary pollutant. Now, I know you guys always go to the rubric and look them up on the rubric, but for someone that was an FRQ on their actual AP exam, and they had to know it, and they couldn't look it up on the rubric. So, make sure that you know those, because they'll ask you about it. Usually acute exposure to these things is life-threatening, and acute is basically, it's short-term, but it's like a high dosage. Where chronic, look at this over here, chronic is long-term, and it's usually low doses. So I would know those words as well. And basically, chronic will cause a gradual deterioration. It'll just cause you to die before you would have died, normally. Kind of reduces your life expectancy. And then a lot of these pollutants can also be carcinogenic, and this means causes cancer. So it seems like almost everything causes cancer these days, but definitely pollutants can cause cancer. So here's some of the effects of some of these pollutants and how they can affect your body. Because another thing that they'll ask on the AP exam, and I think is on that FRQ that I was mentioning, they say, what's a primary pollutant, and then what is a human health effect from that? So one of the main human health effects of sulfur dioxide is bronchitis. It can also mix. It can mix with water in the atmosphere and cause acid rain. And then ozone. So this is important. And students always get confused. So ozone down where we are is really dangerous. It's a pollutant, and we don't want ozone down here. Okay. Ozone way up high in the atmosphere, we do want that ozone layer. Okay, so the ozone down here is bad. The ozone up above the atmosphere is good. So like if this is Earth, ozone here, that's good. Ozone here is bad. Okay, we don't want that. Sorry, I'm saying it backwards. The ozone up here is good because that's our ozone layer. We need that to survive, right? And the ozone down here, I had it backwards. I said it correctly, but then I wrote it backwards. Anyway, so just kind of keep that in mind. Carbon monoxide is actually one of the worst greenhouse gases, and it can reduce the ability of blood to carry oxygen and can also contribute to heart disease. A lot of houses sometimes will have carbon monoxide detectors because it has no scent. It's completely clear gas, and it can kill you if it builds up enough. Nitrogen oxides can restrict lung function and also affect your immune system, so make it more likely for you to get other illnesses. And then particulate matter can cause respiratory and cardiovascular disease. I actually have a brother-in-law. He is an engineer, and he works with a lot of like building materials and stuff. And he's actually developed what this COPD basically from particulates in his shop. Or his I guess he calls it, but it's like a shop. Um, so anyway, he's actually developed COPD, and he's very allergic to, like, he can't be around cats or dogs at all anymore. Um, he has an inhaler. He has to have sometimes nebulizer treatments. He gets hospitalized for it because he can't breathe. It's basically from working with stuff like that all his life. And he's not even very old. I think he's 30 maybe. But anyway, so COPD is chronic obstructive pulmonary disease. And it's a slowly progressive lung disease, and it does affect your ability to breathe. It's the fourth leading cause of death in the United States, and most people get COPD because they're smokers. My brother-in-law is not, but a lot of it from smoking, and it involves like emphysema, bronchitis, asthma. When smokers have emphysema, and a lot of times smokers don't die necessarily from the lung cancer. They die from the emphysema or the COPD as a result. I had a friend, and her husband had lung cancer from smoking, but she said that he actually, the cancer wasn't what killed him. It was actually the COPD. That killed him. He just couldn't breathe. He got to the point where he couldn't walk across the room. It was from, a lifetime smoking. So lead is a very common they like to talk about on the AP exam. This is a picture I actually got from a review book. It was the best one I could find about lead air quality. And basically, lead poisoning can cause mental retardation, high pressure. Leaded gasoline was cause increased prevalence of lead diseases. And so that's why you'll see that at the gas pump now, they call it unleaded gasoline, right? That's gas without lead in it. They used to have lead in paint and things like that in houses that were built kind of in the 70s. Every time I take my sons to the doctor for their well checkups, the doctor asks us the age of our house, and if there's a possibility our house would have lead paint. So it's just, it still isn't, even though we've outlawed and we don't use it anymore, it still is an issue because those houses are around and things like that. So acute effects can put additional stress on those that have asthma or older. They're less likely to be able to recover from or tolerate these, acute, remember, is short-term but high dosage effects. And then most air pollution deaths are caused by that acute exposure, short-term, high dose effects. And when you think about like chronic, that would be, which is low dosage over a long period of time, that would be really hard to link back to air pollution, because if it's over a long period of time, how do you know that it came from air pollution and not from exposure to something else? So that also might be why more air pollution deaths are linked to acute exposure. There might be some that are from long-term exposure, but they didn't get counted as long-term as air pollution deaths because they were over such a long time. So things that can cause cancer. Diesel exhaust can cause, that's a major source of carcinogens or cancer-causing pollutants. Benzene is in motor fuels, and it's also a solvent for things that are fatty. It'll help dissolve them. You can find it in fossil fuel emissions. You can find it when you burn coal and oil. You can find it in tobacco smoke, which is basically half of our exposure to benzene. And it can cause cancer, blood disorders, damage to the immune system. It's a really pretty little, when you study it in organic chemistry, it's a really pretty little molecule, but it's actually not super safe. Then heavy metals. The most dangerous heavy metals are lead, mercury, arsenic, cadmium, tin, chromium, zinc, and copper. And I would remember a couple of these for your AP exam. Lead would be an easy one to remember because it's pretty common. And, where they came from and a human health effect for at least just one. that way you've got it for an FRQ in your back pocket in case you need it. Excuse me. And these are really, really toxic because they're easily absorbed by the body, but they're not easy to get rid of once they're in your body. Organic compounds, benzene is actually an organic compounds, but they link it under carcinogens. These are things, again, they're easily absorbed by the body. They aren't biodegradable, so they don't break down easily in the environment. And they can cause mutations, cancer, birth defects, sterility, liver, kidney problems, that sort of thing. And most of your exposure to synthetic organic compounds is going to be like pesticides and things like that. It's supposed to be a CI. That's where you're going to get most of your exposure to these guys. Then another threat or another pollutant is halogenated hydrocarbons. And this is basically a hydrocarbon where they've taken an H is no longer in there, and instead there's a halogen. So it's going to be like chlorine or fluorine or something like that. And you can see here this list, the Dirty Dozen of chlorinated hydrocarbons. If you ever read Silent Spring, she talks about these a lot. You'll see aldrin, she'll talk about that, chlordane, DDT, dieldrin, she'll talk about that a lot. I think she talks about heptachlor. She might talk about this hexachlorobenzene, but I know she talks a lot about aldrin, chlordane, DDT, and dieldrin. She talks about that a lot in Silent Spring, and those are remember, those are things, again, they biomagnify, and they were causing the bird eggs basically to become very, very soft, and so the babies weren't hatching. So a hazard is basically anything that is going to cause injury, disease, or death, damage to personal or public property, or deteriorate or cause destruction of environmental components. All of those things are considered hazards. Excuse me. Tobacco use is basically the leading cause of death in the United States. It's very, very dangerous. And it's the 4th cause of death globally. So it's really dangerous. I think there's some facts in here, but basically, I mean, like, what other thing is so common that kills 50% of the people that use it, right? I mean, if there was any other thing that killed 50% of the people that used it, people would like freak out and they'd want to, outlaw it or whatever and not want to use it. But anyway, yeah, here it is. It's the only known product on the market that kills half of the people that use it. I mean, talk about Russian roulette. It costs the United States $193 billion in healthcare costs and lost job productivity. When my husband and I sign up for health insurance, we have to make sure that we mark that we are not smokers, because if you are a smoker, they charge you an extra premium on your health insurance because they know that you're going to get sick more often and you cost more to insure. So that's another thing. And adult smokers, luckily, have dropped from 42% to 19.8%, so less than half. But still, almost 20% of the United States population smokes, and it's going to kill half of them. Secondhand smoke is still dangerous. So even if you don't smoke, but you're around people who do a lot, you can still get cancer. It's considered a Class A carcinogen. Basically, the filter is on the user's end, and it is a significant killer of children who don't even smoke, and a lot of times they don't even have a choice, right? They are forced to live in their parents' house or whatever, their grandparents or whoever smokes. They're forced to spend time with them. They don't know to say, oh, I'm whatever, because you smoke. I had a friend in elementary school. Her mom smoked a lot, and she smoked in the car with the windows up. And my friend was always absent from school. She had really, really bad asthma. She was always sick, coughing, that kind of thing. And it was basically because her mom smoked. And her mom was like slowly killing her. Just really bad. there's another sort of thing that they talk about called third-hand smoke, which a lot of people don't mention. And third-hand smoke is basically smoke that is residual on like furniture and clothing and things like that. So like I have some friends and they have relatives that smoke, but they say, oh, we won't smoke around your baby. And they say, well, there's still nicotine and other chemicals on your clothing, on your furniture, on your especially textiles, so like on your couch or blankets or anything like that at your house. And so, it's still the kid will still be exposed to that. I know some people that actually keep a set of clothing at their house for the grandparents. And so as soon as the grandparents get there, they change out of their clothes and they put them in the garage or whatever, and they change into their new non-smoking clothes. And that way they're not going to get their grandkids sick or anything. Or they could just, stop smoking. But anyway, perc is another thing that is very dangerous. It's colorless, it's non-flammable. It's a major substance in dry cleaning fluid and shoe polish. Short-term exposure can cause fatigue, headaches, dizziness, unconsciousness, and long-term you can get liver and kidney damage. And it can also cause cancer as well. There are other organics, phthalates. They soften toys, and they're toxic to the reproductive system. Toys, right, for small children, and yet they have these things in them. Bisphenol A is in many plastics. For a while, bisphenol A was actually in baby bottles, right? And it can contribute to obesity, diabetes, infertility, and cancer. Most bottles and plastics now are BPA free, because people are kind of getting aware to the issue. But, perchlorate is in rocket fuel and baby formula, right? Who thought that those two things would have something in common? And it can interfere with your thyroid. So how do we get rid of these things? We have these chemicals. Sometimes they're necessary, like in industry and things like that. So how do we get rid of them? Deep well injection, surface impoundments, and landfills are the three most common ways, legal ways, of getting rid of these things. So with a deep well injection, you'll drill a very deep hole below the groundwater into rock. Then they'll put they'll seal the well, and then they'll put the waste in there, and they're isolated with like casings and pipes and things like that. And they use this for volatile organic compounds, pesticides, fuels, explosives, things like that. We just inject them very, very deep into the ground. There are other things called surface impoundments. They're basically excavated depressions, kind of like they're called ponds, and they drain liquid waste into them, and they just hold on to them. This is the least expensive and most widely used method because it's cheap. 2/3 of these contain hazardous chemicals that carcinogenic chemicals, and over half of them also lacked a liner, so they could drain, percolate into the groundwater. A lot of these surface impoundments are now Superfund sites, where when I say that, I'm saying Superfund. I'll write it because it always sounds like I'm saying Superfund, like it's something I really want to do. But Superfund sites are basically sites that are designated as being dangerous of some sort or needing cleaning, and the federal government cleans them up. There is something called the Conservation Recovery Act, RCRA, and it basically sets standards for hazardous waste disposal in landfills, so you can't just put it straight in there. You can see in the picture, they put them into drums, they collect them, they treat them, and the treatment standards are established by the EPA, and they're called best available technologies. And so they're basically like the best we to do with them. And they can only be disposed of in secure landfills. So not any type of landfill can take this. You have to be a special secure landfill. Now, some illegal ways of getting rid of waste. There's something called midnight dumping. People will dump hazardous waste in any location, and they usually do it at night so people can't see them, and they'll just put it somewhere. And then there's also something called an orphan site, which again can be, some of them can be considered Superfund sites. And they're basically abandoned sites. They're businesses that stored hazardous waste on the property, and then they went out of business or they left the property, or for some reason they just, but they left the waste there. So those are called orphan sites. So problems with mismanagement is obviously we have to clean up this mess, right? We have to regulate the handling and disposal of this waste. And then we need to reduce the quantity of hazardous waste produced so we don't have as much to deal with. So public health issues, we need to ensure safe drinks. And here I have the MDG, and it says again, basically there are these things called Millennium Development Goals. I don't know if you talked about them in the first half of environmental science, but basically there were some goals by the millennium. We were supposed to, meet certain requirements for safe drinking water and maternal health and, things like that, food. And I think pretty much none of them were made. We made progress, but none of them were actually made. And safe drinking water was one of the Millennium Development Goals. And then cleaning up and isolating the source of the pollution, which a lot of times happens through Superfund. Here we go. So the act is actually called Comprehensive Environmental Response Compensation Liability Act of 1980, or some people call it CERCLA, but also it's known as Superfund. So like if you're doing an FRQ, you could say Superfund and you would get credit for that, or you could say CERCLA and you would get credit for that. So you can do either one. Basically, they put a tax on chemical raw materials, and that tax is put into a trust fund. And then they identify chemical waste sites, and then they try and clean up and remediate it. And so the most, not the most dangerous, but the most like urgent Superfund sites are ones that affect groundwater or have the ability to affect groundwater, because they're basically trying to protect water that we use. And so they can try and remediate the groundwater and clean up the sites. And so that's what you spend the money on. So when they ID the sites, again, like I said, they current potential threats to groundwater are assessed. If the threat exists, they take the most expedient measures, like they do something very quickly to protect the public, and then they can go back and kind of fix it later. But they do whatever they can to protect the public ASAP. And then the worst sites are put on the national priority list, and they are scheduled for completely and total cleanup. If the waste is in drums, they can pick up the drums, they can treat them in management. That's easy. The problem is when either the drums have started leaking, or maybe they weren't put in drums. Maybe you had one of those surface impoundments that's leaking. So this is going to cause the soil to be contaminated. They can excavate that soil and they can burn it, basically, which gets rid of the chemical. And then they can either put the soil back or put different soil back, but they have to do something with that soil. They can put it in a secure landfill, but it's, somehow they have to get rid of it. There's something called bioremediation, which is super, super cool. I met a lady once. She was from somewhere in Africa, and she actually worked on bioremediation for her PhD, and I think she worked on sunflowers. She was working on planting sunflowers and to clean up waste sites. So basically, bioremediation is when you take an oxygen or an organism, you inject it into the contaminated zone, or if it's a plant, you plant it. And then those organisms basically eat the pollutants, and then they die when the pollutants are gone. And then you can just, scoop up the plants or whatever, and then you can incinerate those and send those to the secure landfill. But at least you don't have to put like detergents and other cleaners into the soil. So it's kind of a natural way to do this. This is, if it's a plant, they technically call it phytoremediation. And the plants will also stabilize the soil, which prevents the contaminants from moving, right? You're not going to have as much erosion. And it basically extracts the contaminants when the plants are done and the area is clean, the plants are removed and then they are treated as toxic waste. So they are incinerated and then sent to the special landfill. They can only be used where the contaminants are not toxic plants. So obviously if you have a contaminant that is going to kill the plant, it's not going to work. But for example, they found that sunflowers can take up uranium, poplar trees can take up mercury, and ferns can take up arsenic. So it's kind of a neat idea rather than treating chemicals with chemicals. So for Superfund, more than 47,000 sites are considered Superfund sites, and interestingly, some of the worst sites are on military bases. It takes about an average of 12 years and $20 million to clean up these sites. So it's not quick. It's not like, oh, it's a Superfund site, and then like next week, oh, it's clean, it's good to go. It takes a really long time to clean up a Superfund site, right? If you're having plants extract the chemicals, or organisms get rid of the chemicals, or however you're getting rid of the chemicals, it takes a long time to do. It's not instantaneous. There are other things called brownfields, and I've seen them mention brownfields on the AP exam as well. They mention them in the FRQs, they mention them in the multiple choice section. And these are basically like abandoned industrial facilities where they can't develop on them because there's either some real or perceived environmental threat or contamination. So, and this is actually the official definition of a brownfield. It's basically $2 trillion of real estate in the United States. A lot of times these brownfields are in disadvantaged areas, but what they're starting to do is they're starting to reclaim these brownfields and fix them up. And so they turn what was previously a liability, something that was an eyesore, supposedly contaminated or whatever, and they're turning them into assets, whether they're parks or whatever. They're cleaning them up somehow. There's some other ways that we can control pollution. We can add a filter to a smokestack or something like that, and that easily prevents pollutants from entering the environment. It's a cheap way to do it. You can still use all your chemicals that you're already using. You can just add the little filter, and it protects the environment. It's a cheap way to protect the environment. Then you can also change your production process so pollutants aren't produced in the first place. So for example, if you are using a certain pollutant, like say you're using mercury or lead, let's do lead since it's so common. So let's say you're using lead in making paint, right? Well, in order to prevent this pollution, lead pollution, right, you could just stop making lead-based paint and use something else to do paint, right? And then that's not gonna, and then you won't have that pollution in the first place. So that's, obviously the preferred method is just to use something else. But when there is no other option, or we haven't figured out one, or the company just doesn't want to, you can always do some sort of pollution control instead.